Hey everyone, welcome to the first in my series of game development vlogs. I'm doing some dev vlogging with my new project. I'm working on a project that I'm calling Toy Engine, and basically it's a way for me to learn about graphics rendering, OpenGL, and low-level graphics and game development. I've been developing the project for about a month now, not even 2 months, so about a month and a half. We're at the kind of very early stages with this project. So yeah, let me open up a demo and show you where I'm at with it. So currently I have a basic scene working in it with multiple point lights, directional lights, and spotlights. So here you can see I got two game objects that I downloaded, and I can do some basic manipulation, such as translation and rotation, using the GUI that I built using the IamGUI library. So in here, you can see I got five different lights. Yeah, one, two, three, four, five. So 3-point lights and a directional light. Each of the lights is a different color, and and you can control the strengths of it. I'm currently using the Phong shading model to model this. So we have a diffuse texture, we have a specular texture, and we have an ambient texture. And we're adding those three layers together to uh, compute the output color. So yeah, you can see no skyboxing, but that is planned for the future here. But currently we just have a gray background. We have input events, so I can go ahead and move around in my scene. So this is doing input polling to get the events. And we also have an event handling system, which currently right now only handles um, mouse events, so that when the mouse moves and application closing. So yeah, that's where I'm at. It's been about a month of work. Uh, Let me show you some of the overall architecture of the application. So here you can see we got some input logging. I'm using SPD log for this. And a lot of the work I've been doing has been based off of the Learn OpenGL series, which you can see over here. Um, and this game programming patterns book and uh, and a game development series on YouTube. In this first phase of development, I've really just been working on the core application features. You can see in my development phase plan, I have foundation. I'm trying to work out the basic application framework. So this is building the project, windowing, event handling, and memory management. So kind of the key things I was trying to accomplish in this phase was handling keyboard input, mouse input, input polling, and event integration, and having an eventing system. Some of the developer tools I've been using is SPD log for logging and Premake for build configurations, and of course Git and GitHub. So let me show you an overview of how this application works. So I think we should start off by jumping in at the entry point here, which is kind of very simple and small, but shows kind of the overall picture of it. One of the key things to note here is this create application function, which is defined by the client application and not the toy engine, game engine itself. So you'll see over here let's actually first start by looking at our solution structure. So I have, let's see, so you can see over here we have applications, which is the actual C++ uh, .exe. So this will build to an exe. Everything else is a library. So we have our dependency. So I'm using asset import management. So this is importing the models. I'm using GLAD for OpenGL bindings. GFLW is the windowing library, and IamGUI is the GUI or library that I'm using. Toy Engine is the core of the application. So this is a static library that contains um, all sorts of event handling, layer management, platform dependencies, and the core of the engine architecture. So whenever you want to build an application using Toy Engine, you simply include the Toy Engine header, which includes all the headers that you need to build an application using it. So it includes the logging library, the application header, the layer header, models, and the headers for rendering and locating different services. So and then of course, it includes the entry point. So you include this in your application.ccp or CPP, excuse me, and that adds the entry point. And to define your own toy engine application, create application function to your application and return a new instance, a pointer to your application, and that kicks off the whole process. So here you'll see, we'll come over here, um, applicant in entry point. We initialize logging, and then we call this create application function that you define in your client application, which then go creates the application and the constructor for, where is it over here? Um, oh, sorry, I'm in the wrong. Oh yeah, so it calls the constructor for your application and the constructor for the toy engine application. So a lot goes on in the constructor of the toy engine application. Um, if we look over here, so the constructor calls creates a window, and it initializes the time step service and the input polling services. It also creates a new IAM GUI layer. This is for handling all sorts of GUI events, and it initializes the renderer. In this create window function, we define a new GFLW window, and we set, more importantly, is we also set event handling. So we set the callback function for our window events. So let's see, where do we do that in here? Oh yeah, we do it by setting this use pointer, GFLW set window user pointer function. So that's responsible for setting callback, so data in the application. Let's see. Okay, so back to our entry point. So after we've created the application, we then run the application, which this is our main run loop here. So this continues to run this line 11 until we end our application or close the application. So this is our main game loop here. So in the game loop, we're updating the time step every iteration. So this is required this is used in all our update functions here. And then below, we call update on each of the layers in the application. So basically, every viewport or editor is defined as a layer. You can see over here in our editor, the core of our game is defined as this scene layer. So in this scene layer, this is when we define, our shader library, what shaders we're using. We create the lights. So this contains all the information about what's going on in the game scene that you saw previously. And then on every frame, we call update on this layer. And then on each update, we perform input polling to update camera positioning. And we also update the light positioning and color based off of changes made by the GUI. So here we're setting the light direction and values and position to the values determined by our GUI inputs. So back to our run here. So after we So after we update the time service and then we update we call update on each of the layers, we then draw the GUI. So this will basically go through all the layers once again and look for an IAM GUI on IAM GUI render event. And if a layer has that defined, such as what we have over here in our editor scene layer, then it will go ahead and run all of the instructions in that layer. So this is where, we're creating new windows and we're setting the values of those fields in that window. So going back to the run loop here, and then after that, we end drawing the GUI layer, and then we call window update, which basically just switches the frame buffers and calls for events. So it updates, looks for any new events that have occurred in the window. And this loop continues to repeat until the end of the game. So I guess another big question is, where does rendering calls come into? Currently, those rendering calls are happening in the editor scene layer. So we can find those on its on update function. So looking in here, you can see draw scene, which basically in our update function in the scene layer, we have draw scene, which basically goes through, sets the camera for what camera we want to render the scene with. So right now we just have a uh, member variable called nCamera that defines our camera. We pass that to the renderer. Then I have a shader library. So when you create shaders, they get added to the library, and you can retrieve shaders by using a dictionary or hash table lookup based off of a string value, which returns a reference pointer to the shader. Um, you then call use shader on that, which initializes and tells OpenGL that this is the shader that you want to use when rendering models. And then you go ahead and update the parameters um, in that shader by using the set function. So if you want to set a vector 3, you use set float 3. If you want to set a Boolean value in the shader, you use set bool, and you get the idea here. So all in here, we're updating the scene lights. After we update the scene lights, then we update the model vectors. And for this, we're using uniform buffers, which were useful for the updating the camera matrices. And then at the end, so on each one of those, we're submitting the model that we want along with the shader that we want to use to render it. So if we look in this render submit function, you'll see we call use shader, which sets the shader that we want to use, and then basically goes through the model and gets each of the meshes in the model and finds the correct texture and calls render the render command on that mesh. So I guess with that demo showed, let's talk about what I'm planning on working on next. So currently, I have an application that runs with a window in basic OpenGL contexts. We're able to render, I long ago rendered the simple triangle. We can handle mouse and keyboard events. We have a basic logging system, and we have a build system based on pre-make. So now I've kind of moved on to my second phase of development, which is kind of a basic rendering pipeline. We've integrated a 3D math library with GLM. That's one of the project dependencies. We've built a basic camera system based on Learn OpenGL, and we can render meshes using ASIMP library. So we're able to load in meshes and textures and render them by sending them to the GPU as vertex buffer objects or vertex array objects. Excuse me. We also have a basic lighting system. So I have a phone lighting model with directional lights, point lights, and spotlights. And we have a basic material system for diffuse, specular, and normal mapping, as well as just shader library. Currently, my next step that I'm planning to work on is developing a scene graph and scene management. As you can see, my scene layer is kind of just a mess. Everything is just piled in there with no structure. So I would like to create a hierarchical scene organization, maybe using a list or a linked list structure. So like every entity or object in the scene has has a vector array of children objects as well as a pointer to a parent object. And we start with a root node and we just kind of keep iterating through that tree called making render calls. If we do this, we could have some sort of parented transformation structure, which would be interesting, I think, and worthwhile. So if you move a parent object, then it moves its children object, and then we can do some basic Fulcrum, I always say this kind of wrong. Volkstrom calling. So basically, if an object is outside of our view angle, then we don't see it. Then it doesn't get rendered. Currently, right now, all objects that are submitted to the renderer are receive a draw call, even if they're not visible. So this is an obvious optimization we can make to improve our rendering. We could probably also add like a rendering queue. So right now we have just kind of forward rendering where an object gets submitted to the renderer and an immediate draw call is made. So I think um, really working on implementing a better scene management and scene graph hierarchy would be extremely valuable. Also, I need to implement a basic file manager. So right now you can see, I don't know if there's an example of this, maybe in our editor, you can see we're just calling relative paths. So this isn't ideal. Yeah, it's gotten the job done up until this point, but if I can build a basic file manager system, then we could just, for instance, call like the file manager flat shader, and it would be able to locate this file on in the drive or in the Explorer. And yeah, I think for now that's where I'm going to be. That's going to be my next update. So uh, that's it for now. If you guys have any questions or suggestions or resources that I should look at to improve my learning and build a better game engine, I'm really open to that. I think ultimately what I want to get done is I want to have, physically based rendering, some shadow mapping, some post-processing would be cool because I'm thinking like it would be cool to add like a post-processing shaders to do like interesting like pixel or bloom effects would be fun. I don't know if I'll get to skeletal uh, animation. I'm trying to aim to get this done by the end of the summer, and that seems like kind of a big task. So um, yeah, that's where I'm at right now. Um, Hope you guys found that interesting and look forward to the next game development log.